Assalamualaikum warahmatullahi wabarakatuh to all the viewer and to my respected lecturer, Associated Professor Dr. Hafiz Binti. Before going through, let me introduce myself first. My name is Masyimaisarah Binti Mohd Zain 1180842 and I am from second year of Applied Physics. And the task given for me is to make a video about Lanthanide and Actinide. I hope this video can give some info for you and I hope you will enjoy it.
In the modern periodic table, two additional rows below the main body of the table as part of the table 6th and 7th row are Lanthanide and Actinide. These two rows of elements are placed below the main table because they don't fit into design without making the table confusing. However, these two rows of elements are metals, sometimes considered a subset metal group. In fact, the Lanthanide and Actinide are sometimes called the inner transition metal, referring to their properties and position on the table. Two ways of placing the Lanthanide and Actinide within the periodic table are including them in their corresponding row with the transition metal, which make the table wider, and ballooning them out, making a three-dimensional table.
Now, I will explain to you the first element, which is Lanthanide.
Lanthanide, also called as lanthanoid, are 15 consecutive chemical elements in the periodic table from lanthanum to lutetium. The lanthanide are the elements in the top of two rows located below the main body of the periodic table. Atoms of this element are characterized by having a partially filled 4F sublevel. All of these elements are metal, specifically transition metal. They share several common properties. It has the atomic number range from 157 to 71. There are some dispute over exactly where the lanthanide begin and end. Technically, either lanthanum or lutetium is a D-block element rather than F-block element. Yet, the two elements share characteristics with other elements in the group. Lanthanide elements are lanthanium, cerium, praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, helium, erbium, thulium, ytterbium, and lutetium. The first characteristic is the lanthanide metals are soft. Their hardness will increase across the series. The lanthanides are distinguished by high chemical activity. They form stable oxides, halogenide, sulfonide, which react with hydrogen, carbon, hydrocarbon, carbon monoxide and dioxide, nitrogen, and phosphorus. Metals decompose water slowly in the cool, more rapidly at elevated temperature, and readily dissolve in hydrochloric, sulfuric, and nitric acid. Next, resistivity of the lanthanide metals is relatively high, ranging from 29 to 134 microohm centimeter. The lanthanides are strongly ferromagnetic. Gadolinium become ferromagnetic at below 16 degrees Celsius. The other heavier lanthanide, which are terbium, dysprosium, helium, erbium, thulium, and ytterbium, become ferromagnetic at much lower temperature. Besides, compared to most other non-dietary elements, non-radioactive lanthanides are classified as having low toxicity. The lanthanide obey the Odo-Harkin rule, which means odd-numbered elements are less abundant than their even-numbered neighbors. Cerium and lanthanum are used as catalysts in oil refineries. Europium and terbium used in pixels. praseodymium, and cerium are used in the sparkle of a lighter. They are all essential for laser. Samarium, gadolinium, dysprosium, neodymium, praseodymium form powerful magnet. Lanthanum and praseodymium change the refractive index of glass for use in fiber optics, camera lens, and welding goggles. Thulium used for devices such as nuclear batteries, satellites, and portable X-ray machines because of their radioactive.
Now, we move to second element, which is actinide.
Actinide, or called as actinoid, is at the 7th row, which is at F block in the periodic table of elements. It is a special group of metallic radioactive elements. This element usually considered ranging from atomic number 89 to atomic number 103 in the periodic table, have interesting properties, and play a key role in nuclear industry. There are 15 actinide elements. The electronic configuration of the actinide utilizes the F sublevel with the exception of lawrencium at D block element. Depending on the periodicity of the element, the series begin with actinium or thorium continuing to lawrencium. The usual element in the actinide series is actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, istanium, fermium, mendelevium, nobelium, and lawrencium. Actinide share the following properties, which are actinide combined directly with most nonmetals. Next, the actinide may be prepared by reduction of actinide F3 and actinide F4 with vapor of lithium, magnesium, calcium, or barium at 1100 until 1400 degrees Celsius. Actinides are highly electropositive, which implies high tendency to lose electron to form positive ion. Actinide display several valence states, typically more than the lanthanide. Most are prone to hybridization. All of actinide are radioactive. These elements have no stable isotope. It releases energy upon radioactive decay. The next properties of actinide are the metals tarnish readily in air. These elements are pyrophoric, which is spontaneously ignite in the air, particularly as finely divided powder. These elements are malleable and ductile. Actinides are very dense metal with distinctive structure. Numerous allotropes can be formed. Plutonium has at least 6 allotropes. The exception is actinium, which has fewer crystalline phases. They react with boiling water or dilute acid to release hydrogen gas. All these elements are silver-colored metal that are solid at room temperature and pressure. All the actinides are paramagnetic, which weakly attracted by pole of a magnet, but not retaining any permanent magnetism. Actinide metal tend to be fairly soft. Some can be cut with a knife. As lanthanide, actinide also have many usage in industry. Thorium is used in the preparation of fuel rods, which are used in atomic reactors and also in the treatment of cancer. Uranium is used as nuclear fuel machine. Plutonium is used as nuclear fuel and for making atomic bomb. Americium is valuable laboratory source of alpha particle. Actinium used in treating cancer patients, same goes to the californium. Neptunium are used for research purpose.
Now, I will explain to you the difference between these both two elements, which is lanthanide and actinide.
the first difference between lanthanide and actinide is valence orbital. Valence orbital lanthanides are involving in the filling of 4f orbital. Meanwhile, valence orbital actinides are involved in the filling of 5f orbital. Next is atomic number. The atomic number of lanthanide range from 57 to 71. Meanwhile, atomic number of actinide ranges from 89 to 103. Next characteristic is oxidation state. Lanthanide, they have the ability to show a maximum oxidation state of +4. Meanwhile, actinide show variable oxidation state of +3, +4, +5, +6 and +7. Paramagnetic properties of lanthanide can be easily explained. Meanwhile, paramagnetic properties of actinide is difficult in case of actinide. For radioactivity, lanthanides are non-radioactive in nature except promethium. And radioactivity at all actinide series elements are radioactive. The next difference between lanthanide and actinide properties is radioactivity. Lanthanides are non-radioactive in nature except promethium. For actinide, its all elements are radioactive. For oxidation, lanthanide do not have a tendency to form oxidation. Meanwhile, for actinide, several oxidation of actinide series exist. For compound element, it is less basic. Meanwhile, for actinide, it is highly basic. For binding energy, lanthanide completely less than 5f orbital. Meanwhile, for actinide, it is more than 4f orbital. And lastly, for shielding effect properties, lanthanide more effective than 5f orbital. And shielding effect for actinide is less effective than 4f orbital.
So now do you guys understand and know what is lanthanide and actinide? I hope you guys can remember and use it well in your life. Thank you for watching. Assalamualaikum and bye!